So if we do our derivative here, we get 4x cubed minus 12x squared. And then if you make that equals to 0, you can factor out a 4x squared, leaving you with x minus 3. Split it up here, and x equals 0 or x equals 3. Those are the places where your derivative is equal to 0. Putting that on our number line, choosing a number before 0. So minus 1. This will be positive, and this will be negative. Giving us an overall negative means that it's going down. Choosing a number between 0 and 3, like 2, this will be positive. This will be negative. It's still negative. And so we have negative again. It's still decreasing. And then finally, something bigger than 3, like 5, 4, 7,000. Okay, we'll choose 4. Positive and positive, which means that this overall is positive, and it's increasing after that. So we know from this diagram, 0, comma, and if I plug in 0, I get 0. This is a stationary point of inflection. And 3, comma, plug that in, 81 minus, what is that, 81 minus 108? Negative 72? I don't think that seems high. Negative 17? Or negative 27? All right. There we go. Negative 27. And that will be a local minimum. Now, when we go to graph this, we have 0, 0, and 3, comma, negative 27 is our other point. It's decreasing to 0. It flattens out, then decreases again, and then comes back up. We can actually figure out this point without our calculator as well. That kind of connects to some of the way that you would have graphed this using what you learned in grade 12. In grade 12, for graphing this, you would have said we have a positive x4 graph, so we know that it's going to act kind of like a parabola and go up to infinity on both the negative side and the positive side. You would also say that you could factor this by taking out an x cubed, and you would have x cubed times x minus 4. So your x-intercepts, if you made y equals 0, are x equals 0 and x equals 4. So that's why we know that this point is also at 4, 0. Yes? You would already, by finding it, just because you could do the derivative again and see that it would happen again, or? But, oh, like here? Just because this part is always positive? Okay, but this isn't a parabola and this isn't a parabola. Right, but this has an x squared times by an x minus 3. Okay, well, I wanted to point out, we'll come back to that. I wanted to point out that something that you had from last year, okay, with this x3 being 0 and x4, do you remember that this 0 has a multiplicity of 3? Do you remember that? And if you have a 0 that has a multiplicity of 3, then it will have a bend and go through. Do you remember that? If it had a multiplicity of 2 or an even number, it bounces off of its x-intercept. But anytime its multiplicity was an odd number, it would go through. If the multiplicity, like this one, 4, 0, has a multiplicity of 1, and that's why it just goes straight through without a bend. Anytime you have a multiplicity of an odd number, the bigger the odd number, the more drastic the bend, but you get that kind of idea. So from grade 12, you would have known there was a bend, and you would have known it goes through. The thing that we've added now with calculus is we know where that minimum is. From last year, we wouldn't have been able to say where 3, negative 27 would be. So we've added some more detail to our graph.